Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. Today we're going to be looking at retrieving data over the internet using Python. So we're a meetup group, just a free meetup group to help people. We do online and in-person sessions in Brisbane. So about once a month at the moment we're doing in-person sessions, but this one's an online one. But the next in-person session is in 2 weeks' time. So I recommend everyone coming along to that because it's a lot easier to learn stuff when you're in person. You've got people you can ask, and it's a bit easier than asking over the streaming. But anyway, feel free to ask questions here. I'll be watching on the Slack channel. So the Slack Beginners Python and Machine Learning, both in the YouTube and comments and in our meetup. There's descriptions on how to get onto that. So send an email to skypyproject@gmail.com and look at this Learning to Code channel, and that's where you can ask questions. And also you can ask questions just on YouTube chat. Hopefully I will see them if they come through. Okay, let me know if there's any problems with sound or video, but otherwise let's get going. So in the YouTube comments and also in the meetup, I've got a link here to a Collab Notebook. So the first thing you need to do is go to that in your web browser. So try to have the video open in one window and this Collab open in another, and so you can follow along and actually do the exercises as as we do them, and that means it's a lot easier to learn, and you can see what the ramifications of changing different things are yourself. So we're going to be looking at data that's provided by the Brisbane City Council. They've got an OpenData project, so they provide data for a lot of their things. So for example, we've got here the sensors for rainfall and stream heights. So let's open that in a new tab and have a look at what we're looking at. So they've got some metadata, which is all about their some sensors they've got measuring rainfall and stream heights, and there's also some data which is the actual measurements. So they're related data, so we'll be looking at both of them. Okay, I'll better tell you how to use Google Collab first. So Google Collab, you'll need a Google account to do this, and if you open up the notebook that I've provided to you, the first thing to do is make a copy of that to your Google Drive. See there's a button here, copy to drive, and if you click on that, and I'll do that as well, you'll see that you'll get a new copy, and this one means you can make changes to it. You see the other one, it says changes will not be saved. So this one here, you'll be able to make changes to it and save it on your own Google Drive, and you can always go back to the original one to see if you really stuff things up. You can look at the original one, see what it was supposed to be. All right, now a Collab Notebook is a series of text cells and Python code cells. So this one here is a text cell. It's all just markup. I've given you some links to different things that'll be interesting if you want to follow up more on this session. These are our links. We've got the link to this notebook itself, our link to YouTube, a link to our meetup event, and even this is a site on GitHub where we put up all of these notebooks. I actually convert mine to Python scripts, so you can run it even without Jupyter notebooks, and then you and it's got all these links in here. So that's a good starting point, because it's got links to every other thing that's here. All right, here's another text cell, and then we'll get on to these code cells. Now, the first Tuesday of every month, we try to have an absolute beginners session. I think last Tuesday was supposed to be that, but it wasn't. I think it was a little bit more advanced than absolute beginners, but anyway, no one complained, so that's what we got. And the other weeks of the month, so the 2nd to the 5th weeks, we try to do things a little bit harder. So but we're still happy to answer any beginner's questions that you might have. So this first code cell you will recognize as Python. All it is a comment, and the way you recognize that is because it starts with a hash at the beginning, and Google Collab has decided to color it in green. So it says go to the metadata link and find the Python code to access their data. Alright, so this isn't even a Python challenge, this is a how to find data challenge. So we'll go to the metadata link, which is what we did before. We're there, we saw the map, we saw the data explorer, and hidden on this page they've got some Python code about how to access their API, and that will be here under Data API. So if we click on Data API, it brings up this way of different ways of accessing their code. They've got the different URLs that are different ways of accessing it, and then right down here under example Python they give you some example Python code that you can use to access their data. Well, that sounds like my job is finished then if they're giving you the Python code, but it's not. So I'll copy that, and I've actually copied it over here into the solution, and I've put it in comments, so you can see the code. This is the code that was on their website. Now the reason I put it into comments is because it's actually code for Python 2 and not Python 3. So the quickest way to identify code that's written for Python 2 is when people do print statements in Python 2, they don't put parentheses around what they want to print. They just do print and then a space and then what they want to print. But in Python 3, print got changed from a statement to a function, which means that you have to put parentheses around it. Alright, so that's one thing that will have to be changed if we need to convert this to Python 3, which is actually challenge 2 here. Convert to Python 3. The other part of this challenge, well, the other hint on how to do it is that the function URL open in Python 2 used to be part of this library here, URL lib. But in Python 3, that module is now called urllib.request. Okay, so I've got a spare cell here. So I'm just going to quickly do a direct translation using those hints, and then we'll look at the solution that I provided and wrote earlier. Okay, so similarly we're just going to go, well, in fact I'll just copy and paste the whole thing, and we'll just change the bits that I need to. So I'm using control / to get rid of the comments. Import URL lib.request, and then we say URL lib.request.url open, and then as we mentioned before, we have to put parentheses around what we want to print. Now we want to run this, and I could just click on the run, and the first time we click on it, there you go, this is authored by me, so we're going to run it anyway because we trust me. And the first thing it does is it has to connect to the Google servers, and what they actually do is they start up a little Linux box for you where you're running your own Python code. They provide this all free of charge, so it's very very nice of them. And I might just zoom in a bit so you can see it a bit more easily. There we go. So it's still connecting, it's giving us some RAM, it's giving us some disk space. Now it's run the code, which I've just translated straight from Python 2 to Python 3, and it's printed out the results of what it read, which is this byte string, and it's pretty long. There's all the data, and it's got a B out the front, says it's saying it's a byte string, so it's not Unicode characters, these are actually bytes. But they do, and in Python 2 that all strings were byte strings, so that's just another a difference between Python 3 and Python 2. Okay, And we'll get on to more about byte strings, but for now, let's have a look at the way the solution that was provided slightly differently. So I've shown you here another way of importing functions. So if there's only one function you need from a library, you can say from that library import that function, and then you can use the function here without having to explicitly declare where it came from. Here I had to put in the full URL lib.request.url open to use it, and here I can just use URL open. So that's one way of doing it. I will often, if I'm importing lots of libraries, I'll leave it just in this first way of doing it, so that then in my code I can see which of the libraries it came from without having to keep referring up to the top of my code to see how I imported each of those functions. And that's about it. Alright, so let's run this one just to see it gives us the same answer. Yep, that's the same answer, another byte string and the same length. Okay, challenge 3, convert the byte string to a Unicode string using b.decode. Okay, so this is just a Python exercise. How do you convert byte strings to Unicode strings? So if you can't remember, I've even given you it here. It's running that function .decode on your byte string. So let's say my byte string is going to be, I'm going to say, well, let's put it all in one line. I'm going to open the URL. That's going to give me a file object. That file object I'm going to read, and that's going to give me a byte string, and then that byte string I'm going to decode it using an encoding equals UTF-8. And then I run that by pressing on the play button here. And it gives me the results. This time it's a Unicode string. So you see this one had a B in front of it. This one doesn't have anything in front. So it's just the default string for Python 3, which is Unicode. The reason it wrapped the lines was more a function of the way I displayed the result here. Is I just did this, it came up with a result, and Google Collab decided to display it for me. In this one I actually said I want to display it using the print function, and in which case it printed on one line. So that's not really a difference between the two bits of code. So remember, ask any questions, and if you want any more explanation about any parts of this. Okay, so that's one way of doing it. Now another way is to use a context manager when you're using URL open. So we're just learning a few different things about Python here. And what's a context manager is when you use the with command in Python. And what that is useful for is it closes any automatically opened, any opened resources are automatically closed when it exits the context. So this context stays open the whole time we're using indented code, and as soon as we come out of the indented code and back to the normal code, then our context closes, and anything in there that's context manager aware will close with it. So in this case, URL open creates a file object. Here I've just called it F. That file object will be have an f.close applied to it after it comes out of here, but before that we read the results into a byte string, and then we convert. So that's a variable holding a byte string. This is a variable holding the Unicode string, which we got from calling decode, and then we print that one out. So let's run these two bits. So I just use Shift Enter for both of them. It was a shortcut for the play button here. They say that the shortcut is Control Enter, so Control Enter will run the cell and leave you in the cell. Shift Enter will run the cell and take you down to the next one. Alright, we get the same, and see prints it all on one line. Okay, so that's using URL open from the URL lib.request library. That's actually a fairly tricky library to use if you're trying to do anything you'll find you're having to do a lot of work using that. So even on the Python website, they recommend using this requests library, which just makes things a lot easier to understand for the normal things that you want to do. I mean, URL is very powerful, but it's fairly low level, so you really have to understand what you're doing in a lot of cases. Right, now normally if you just installed Python, you'd have to then install requests. So you could do pip install requests into your virtual environment to do that. But the Python that Collab gives us is like the Anaconda one. And Anaconda comes with a lot of third-party libraries already, and a request is one of those third-party libraries that comes with Anaconda in Collab. If you want to check, while you're in Google Collab, these code cells are normally for running Python code, but if you want to run something from the command line, you put an exclamation mark at the front of it, and then you do your command. So pip is a command line command. Pip lists all the third-party libraries that we've got. There's going to be quite a few. So what I've done is I put the pipe symbol there, which is a shell command that says take the output from this command and pipe it through to the input of this command. And so grep request basically says filter the input that I get and only show me lines that have the word requests in it. So let's run that and see what we get. So this is happening in the operating system. This is not Python. It's found 3 libraries that have been installed, and they're called requests oauthLib, and requests Unix socket. So this is the one we're interested in, requests. So we confidently have it in our Python environment, so we don't need to install it. But if it wasn't there, we could just run this pip install requests. Right, now how to use requests. Once again, to use a library, you import it first, so we import requests, and then we can use functions in that library. So one of them is get, and get is an HTTP method, just like post and put and delete, but get's the most common one that you'll use. We use requests to send a get request off to our URL. The URL is that Brisbane metadata one, and we'll get a response, and from the response we can look at the .text property of it, and it will be the results. So let's run that, and you can see it's already converted into a Unicode string for us. So all that work we had to do before about converting byte strings to Unicode strings, request does that for us. It even worked out what encoding it was. So you can see in the response what encoding it thinks the response is. So it says it's UTF-8. So we just looked at .encoding there. If we really wanted the original byte string, we can look at the content attribute or property. And you can see there's the byte string, the original byte string that we had. And we can even look at the headers that came back with that response from the website, and they'll tell us information about the response, and one of them was content type, and so it says the character set in the content is UTF-8. So that's how it worked out. It was UTF-8 and knew how to use that encoding. So that was a fair bit of work. It saved for us just by using the requests library. So from now on, I'm just going to use requests. It also tells us that the data's come back as in JSON format. So JSON is a JavaScript object notation which looks very similar to dictionaries. So they translate very well into dictionaries in Python. So in fact, you could just convert it straight to a dictionary using the JSON library, but once again, requests does it for us. In the response, we can just call the JSON function, and it will convert it all into a dictionary for us. So a dictionary, you can see you've got these fields. They very helpfully give us a way to go get help on their API. They've said our request was successful. It came back as true. We've got a result that had a total, It was limited to 5 records. We had a query running titled Jones. The records format was objects. It had a resource ID of this resource ID and records. This is the actual results that we were looking for, and it's an empty list. So that's not much use to us. But it also told us all the fields that we could expect in our data and what sort they are, whether they're integers or text or float, and gave us this other data. All right. Notice that no data was returned in records. This is because the Brisbane City Council example had a query filter in the URL that doesn't apply to this record set. So challenge 4 is to remove the query parameters from the URL that are relevant and refetch the metadata. So remember the original URL. So this is a URL, and you've got things like you've got your protocol there, so hypertext transfer protocol with security added. We've got the domain, which is www.data.brisbane.queensland.gov.au. Then we've got a path, and these normally related to file paths on the web server operating system, but they this day and age of web applications, they're also interpreted by the web application as a way of navigating through the data that they provide. Now this path goes all the way up to the question mark, but everything after the question mark is what are called query parameters. And the query parameters, so we've got resource ID equals and then a number. We've got, and then they're separated by ampersands. So we've got 3 query parameters, and the other 2 are limit equals 5 and query equals title Jones. All right. So we want to remove the query parameters from the URL that are irrelevant and refresh the metadata. Okay, so let's. We've got the URL. What is wrong with this is title Jones. Obviously, this is a good query for some other data sets, but in the context of rainfall sensors, it doesn't make any sense. So we're going to delete that query from there. Limit 5 says just get 5 records. We don't know that, but it's just as a guess. So we could take it out and just see what happens if we took that out, but I'm going to leave it in. So let's get that URL. So requests is the library, get is the function, URL, and then have a look at the JSON that comes back from it. Okay, now we see in records, we've taken out that query, and we've got a list now of 5 records, and each one of those is one of these sensors, so it's metadata about the sensor, whether it's rainfall or stream height AHD. Okay, so that's my solution. Let's have a look at the provided solution. Anything after the query is a query filter, as we discovered. But in the requests library, using parameters in queries or using query parameters is quite a common thing when you're getting URLs. So there's actually a field that you can provide to the get function. That is the params. You can see here URL and params. And the default is not to have one, but we can split up the query parameters that we had into those. So that was what the parameter was and what the value of the parameter. Okay, so let's run this. So if you look at, I think the URL is included. No. Look at this. So this is the URL that we pretty much had. It's got that resource ID and a limit of 5. Now, if we run this using params, we've still got our queue of title Jones in there, and there's no records, as you can see. And in fact, you can see the URL it thinks, so is limit equals 5 and q equals title colon Jones. There's even URL escape to the colon, as it should do. And now we can delete out of these params the Q query. So remember how to delete one key value pair out of a dictionary, and you can use the Python del command to do that. So delete params Q and get the response. And so this time we should get some records. We'd have, because we've got a proper query. And the 5 as we had before. Oh, here we go. I've got a question. So my, oh yeah, it did show up. So in the YouTube chat, I've got, what is the best resource to learn Python from the beginning? So that's one of the things we're trying to do here, provide beginners Python. So and we're doing it in person, so you can ask questions. And doing it in person is really a great way of doing it. So come along to our in-person sessions. There'll be someone there who can help you. I've found realpython.com. I've got some very good courses on there that get you through a lot of the details. But even the Python website, python.org, they've got documentation there on how to get started into Python. So you really want to get started. Then you want to, so you just understand a few of the basics of Python. And really the first Wednesday of the month is a better week for us to show you that stuff. Google Collab is a really good way of learning these things in Python, because you can just type in really small programs just in a few code cells. So let's just make a few code cells here. You can just type in a equals 2, and you've assigned a value to a variable. Then you can say, tell me what's the value of a, print a, and it comes back as 2. So you can, Google Collab is a fantastic. That immediate interaction with Python is a really good way of learning how to use it. And then so if you're finding that I've done a bit too much today, then that's probably true. I've been, but I can introduce these simple principles as well, and the rest you can just copy and paste and be confident that you'll understand one day what they all mean. So yeah, feel free to ask any questions about any particular part if you think that that's something that you can grasp. All right, challenge 5, get the next batch of 5. All right, so we've got some results here in the data. And there's a link here next that tells us a URL to get the next values. So in fact, we can refer to that just by saying, grab us the JSON, turn it into a dictionary, look up the key result in dictionary, look up links in that dictionary, and look up next in that dictionary. So this is all nested dictionaries. But really, all we're doing there, is this is a dictionary, and a dictionary is just a series of key value pairs. So that's a key, and then we do a colon, and then we do a value. I'll just put number 5, and then we do another key. Let's call it previous, and a value, and let's call it 3. And then if I want to find what the value is for any particular key, then I take my dictionary name, I use square brackets, and then inside the square brackets I put the name of the key that I want to find. So say I want to find previous, and it's even prompting me you can use next or previous, so I'll choose previous, and say what's the value of a previous, and it's 3. So it's gone into this dictionary, it's looked up what the value of previous is, it's 3, and it's returned that for me. And so what is A? A is the dictionary, and so your dictionary you've enclosed in curly braces, the strings are enclosed in quotes, and the integers are just standalone. All right, I hope that helps. All right, but anyway, getting back to challenge 5, get the next batch of 5. Okay, and they provide us with a URL, and the important thing about the URL is that the offset equals 5 and everything else is the same. So I've got, if you remember, actually what I might do, I might share this notebook as well as the original one, so that anyone can you can just see what I'm doing at the same time, if you miss something that's actually on the video. So I'll copy that link, general access, anyone with the link can view. Yep, that's good. And I'll post that into Slack. And I'll post it into YouTube. YouTube sometimes swallows up URLs that people put in there, but try looking at live chat rather than just top chat, and you've got a better chance of actually seeing it. Okay. All right. So let's add a couple more code cells here. So if you remember before, we had a dictionary of params. So just like my little dictionary of A here, it's got a key, a value, a key, and a value. And we just want to add another key and value, which is offset equals 5. And so we can just add that in. And then we can run the request again, which in fact is what I'm doing here in the solution, so I won't need to type that in again. And if we look at the records that we come, they start at 6, 7, 8, 9, 10, and they even say if you want to do the next ones, do an offset of 10. So they're just helping you if you're wanting to write a web application that's going through the data page at a time. It's giving you links that you can recover the data page at a time. All right, now you might have noticed in these URLs we had these resource IDs. So the resource ID for the metadata is this, and the resource ID for the data is that, and you'll see them. You can extract them from the URLs I provided right at the beginning. Okay, so programmatically retrieve data from the download buttons CSV. Okay, so if we look at our data here, we've got a download, and we can download in each of these formats: CSV, TSV, JSON, and XML. So let's see what the link is. Copy link address for the CSV. So I've been going through this, and I've been making changes to the original. So what I'm going to do is I'm going to do it on the copy that we've got here. So you will already be getting all my changes because I just posted the same link, the same share link, which is I was wondering why it was already shared. And this one, let's just run through. So I'll connect this one, and I should have recognized because this is the one that says copy of. So yours will say copy of. And this one for me says cannot save changes. In fact, so there you go. You won't be able to see the changes that I'm making. All right. So let's quickly run through down to challenge 6. Yeah, we got that one. We got that. And here I was going to say the URL for the CSV link from my copy and paste was that, and you can see that's correct, the same as the solution, so that's good. All right, and now this one I will share. That's what I was expecting to see. Anyone with the link, copy the link, and I will share that. Okay. All right, programmatically retrieve it. So I'll just say get URL for the CSV, and then let's have a look at the response.txt. So here we go, we've got the data. You can see here ID, sensor ID. So this is pretty much what a CSV file looks like. You got your first row is going to have your header names, then you have a carriage return line feed, so \r/n, and then your data 1 E1809, etc. Very oddly, in this data, every line after that they just do new lines. They're not doing carriage returns, so it's sort of a mix of Windows data and Unix data. But anyway, we can live with that. And then right at the beginning, it's got this bytecode, and they've displayed it as \UFEFF. Well, Python has displayed it that way because it can't display it as a character. And that's called the byte order mark. And it's designed for when you're downloading bytes we got a file with bytes in it, to know which order the bytes go in. And I've put a link up at the top about byte order marks. But because what you can have, there are 8 bits in a byte, but sometimes people are using longer bits of data that are longer data fields that are more than 1 byte long, so they're 2 bytes long. And so for bits up to 16, some computers put the big byte first. So it's like, say we were doing it in decimal, if we had the number 21, some computers would put the 2 before the 1, and other computers would put the 1 before the 2. And so the byte order mark just says which order are the bytes going to come in. Is the 2 going to go before the 1, or is the 1 going to go before the 2? So in Intel chips, they actually do put the 1 before the 2, so the 1 before the 2 of the 20. So it does seem odd to me as a way of doing things, and that's called little endian. And things like the PowerPC chip, which is an old chip, that used to put the big before the little, so it's called big endian. So it was 2/1, 2/1. In networks, when you're traveling across the network, they always do the big before the little, so they always use big endian for network byte order. And so if you're doing something like UTF-16, which is Unicode characters made up of 16 bits per character, then that's important to know which order they come in. When you're doing UTF-8, it doesn't matter because it's all 8-bit bytes, and they just come in the order specified by UTF-8. And so it's got nothing to do with the byte order mark. So UTF-8 specification actually says don't put in byte order marks. So it's very strange that the Brisbane City Council has put in byte watermarks, but if you look at the URL that we sent, we basically said BOM equals true, saying we wanted a byte watermark. So really we could change that just by not putting that bit in, and we'd get all this data without the byte watermark. So that's the URL for the CSV. This is the same URL, and I've done it with a an F string, and I've filled in this resource ID part of the URL using the resource ID data that we had before, and I've taken off the BOM equals true. I put into the parameters, and so let's run that. URL data resource. Yes, and that's because I didn't run this cell. So I'll run this cell first, and then run this cell. So there's the response with the byte watermark in there, and it's put it on the field name. It thinks it's part of the field name, so that's really not good for us. So let's do the same thing without the byte watermark. Okay, and I'm going to teach you some more things that we can do. So you can see this data has come through, and this is a CSV file. We've got our headers on the first row, and so if we look at the data, and I think we'll go look at the data in their data viewer. So this is the measurement data. So I'll go open in the new tab. And this is what the data looks like. So it's on each row they've put a separate column for each of their sensors and the value that they've measured in it, and they've got these dashes when they're, I don't know what dash means. It means either they haven't measured it or it hasn't changed since the last measurement. So I really don't like this this way of formatting things, but I've come from a database background where everything's row based. If you're using pandas for your data science, that's really a column based. They really like column based stuff, so this will suit you just fine. Having all the columns, all the data. Every time you want to add a new sensor, you just add a whole column to the end of your data set. All right, now we're going to use a CSV library that comes with Python. And the CSV library is designed for opening a file that's been saved to your drive. And so it reads in a stream of text from the file, and it converts it into a list of, we can do, say, a list of dictionaries for each row of the data. So it assigns values to each of the headers that we've got. We don't have a file on our drive. What we've got is a network connection. So this is a little bit esoteric, what we're getting into here. So we've got our response is some text, and that's just stored in memory. Now we could save it to a file, and then we could read the file in using the CSV library. But Python provides us with an I/O library, I/O input/output, for doing things where you want to treat stuff that's in memory just like it's a file. So like we're inputting data from a file. And so in this case, because we're using Unicode strings, we want to use the string I/O part of that. And so the technique is we take our string, which is response.txt, and we pass it into string I/O, and that gives us a text stream. And the reason we use streams is to really save on the memory usage of your program, because you don't have to load everything into memory at once, although in this case we're doing it through in-memory streams, so it's sort of defeating the purpose. But CSV was designed to read quite large files from the drive without having to have the whole file in memory at once. So it comes in through a stream. A stream goes into this dictionary reader and then gets parsed, And then that creates what's called an iterable value, so we can create a list out of it, and then we can look at the first 5 rows of the list. So there's a lot going on in those few rows there. Let me know if you want me to go over that again for you. All right, so this is the data. It's a list of dictionaries. So we can see we've got a key and a value. So the first value is 1 for ID. The second value is 2 for ID, 3 for ID. Then we've got the date that it was measured, stored as a string. So you see it's got quotes around it, so it's a string. And then we've got each of our sensors and what the measurement was for that sensor at that time, or not measured at all. All right, so that's how to read a CSV file over the internet. We could also have downloaded the file and worked with the downloaded file from the, and we can do that from the command line. So in the command line, we've got a curl function. We're going to output it to data.csv. So let's run this. So that goes to the same place. I've said don't use the byte watermark. It's downloaded it for us. It's 68,056 bytes long. And if you want to see the files that you've downloaded, you can look at them over here. Data.csv, there it is. We've just downloaded that file just by clicking on the little folders there. Those files will get deleted at the end of your session, so don't put anything in there that you want to keep. We can also create the file ourselves. Because remember, we've got all the bytes here in our response.content. We can write the bytes, WB, to a file of our own calling using a Python command, and we just write those bytes. And if we do that, that's been written, and now we can do a ls, which is like dir but in Unix shell. And there's our 2 files, and they're both exactly the same length because they've downloaded the same data, 68056. So different ways of doing things. All right, so that's CSV files, and we're showing you how to get it into a list of dictionaries. But sometimes they come through as tabs separated rather than comma separated. So what options have we got in CSV? So CSV, they've got this function list dialects that tells us they've got some built-in ones, Excel tab, and Unix as 3 popular formats for CSV files. We've just done Excel as the default. But we're about to do TSVs, which is tab separated values. And so we'll use Excel tab for that. Okay, challenge 7, create a list of dicts using a TSV file. And that tells us how to do it. So if you remember before, if you look at this, I downloaded these links by going to the button and just downloading each of the links just to look at how they're different. And they're all actually pretty much the same. They've all got the same URL. It's just the parameters that change. So this one is format equals TSV, format equals JSON, format equals XML. Well, that makes it really easy for us. It's so easy, I'm not going to bother typing it. So remember before we had the same URL for the data, but we just have to change, supply one parameter, format TSV. We run the same thing through response.txt into our stream. We tell the CSV dict reader that we're now using the dialect Excel tab. And let's have a look at the first 5 rows of that. And we'll also have a look at the text that came through just to check that it is in fact tab separated. So here, there's the first 5 rows, and here's the text. As you can see, there's our first ID, and then a tab is \t measured, then \t and a sensor ID, then \t. So yeah, that's all tab separated. All right. So hopefully this session is useful for data scientists, and so I'm just showing you as many different ways, and you can choose the one that really works for you. If you're using pandas, pandas can also read CSVs straight from a URL. So I just use that same URL data with no parameters in this case because we're going to use the CSV version. We just tell it the index column is ID, and just in 3 lines, pandas does all that work for us. It gives us the ID and measured and all the sensor readings. And in fact, in this case, I would really want the index column to be measured. So let's see if we can do that. That's right, measured. So the time that it was measured is the index. ID is not really useful because the same measurement 10 minutes later is going to have a different ID. So I really just throw that column out. And there's all our sensor readings, all in columns because pandas loves column data. Right, so I said I'd show you XML as well. XML is a really big topic, and that's because the XML format is quite comprehensive in what it can provide, and actually is so comprehensive. There's security issues with reading XML. You have to be a little bit careful about it. I'd recommend, in this case, just using a library that you're familiar with. So if you've done my Meetup 70, and the link's up at the top, on web scraping with Beautiful Soup, then there's probably one to use. We need to make sure that we've got these two libraries installed if we're going to run using Beautiful Soup, and they are, so that's good. So we get the URL data into our response, and we provide the parameters format XML, and then we take that response text and create a soup out of it, and then we've got all the features of Beautiful Soup, which are not necessarily great for getting it into a list of dictionaries, and that's because Beautiful Soup actually does a lot of the work for you, so you can go straight to the data you want. But in this case, I do want a list of dictionaries. So let's have a look at what the first row in our soup looks like. And that's what it looks like. It's all the so the XML format. We've got a tag and then a value, and then it close the tag, open the tag, value, close the tag. So that's how XML looks like, and we need to convert that into our list of dictionaries. So what I'm going to do, I'm going to use the find all command. It's going to find each of these rows. So soup.row just found the first tag that was called row, and that's really all the lines are going to be called rows in this list. We can have a quick look at what it looks like. That's how the data comes. So it's data nested in, and then rows nested in data, and there's a whole bunch of them. All right, so I'm just going to loop through those rows, and each one of the rows, we'll take the ID is the row ID. So that'll be 1, 2, 3, 4, 5, and the reason I've done that is because the ID is actually here as an attribute of the XML tag, and every other piece of data is in the contents of the tag. So measured is a tag, the contents is this value here. E1809 is a tag, and the contents is 0. So we're then going to create a dictionary of all those, every child in each row, and store that with the child.name, which is the tag name, and child.string, which is the text contents of that tag. And append them all to the list, and then just display the first 5 rows of the list. So this little bit of code here, we'll run that, and once again, just like every other time, we've got 5 rows of data, and it's the same data as we had for the other formats. So I've gone through those 4 different formats, like I said, and we've also tried using so we've used download links, and we've also used the API links as different ways of retrieving data from Brisbane City Council OpenData project. And once you've got lists of dictionaries like this, then you can use them in any of your projects. You can convert it into ways that you need that data. Next week, we'll be looking at databases. So this same data, we'll be showing you how to put it into an SQL-like database, which is more row-based rather than column-based. And so there's a fair bit to learn on that. And then once it's in the database, you can run queries and filters and update data and reports from that data as well. So that'll be an interesting one as well. I hope you've learned something. Please ask any questions. As soon as I close this down, the YouTube chat will stop taking questions, but you can ask questions in the comments below the YouTube, or you can ask questions in Beginners Python, there's lots of people looking at the Beginners Python, so you'll get an answer from someone. Remember, in 2 weeks' time, we've got an in-person session on machine learning, and it'll be Arun taking that one, and that'll be in the Queen Street Mall at the Brisbane Business Hub, which is in the old Regent Theatre. It's a very nice location, so please RSVP to that one and come along for the session. It'll be a lot of fun, and yeah, I hope you've learned something tonight.